Engine repair 2, test 2. In a single overhead cam V8, how many camshafts do we have?
4.
Wait a minute. What does single mean?
Oh, my goodness.
How many banks are there on a V8? You got left bank, right bank, single overhead cam, one camshaft on each head, right? The coolant flow through the radiator is controlled by what?
Wait, what was number 1?
Engine repair 2, test 2. The one that was laying on top of your...
Yeah, what was the...
Oh, the first one, a single overhead cam. If it's only got one overhead cam on each head, you're going to have an overhead cam for each head. If you've just got one head and it's single overhead cam, you're going to have one camshaft. If you've got a V8 or a V6 and it's single overhead cam, you're going to have one cam for each head, aren't you? It was laying right on top of your pile there, buddy. That's the one. All right. Don't fall behind. Number 2, the coolant flow through the radiator is controlled by what? You guys have done this before. What is it that stops the coolant from flowing through the radiator until the engine begins to warm up? Thermostat. That's not a hard question. Sometimes you can ask a question the wrong way and people will be confused by it. Okay. A normally aspirated automobile engine loses about how much power per 1,000 feet of altitude? Actually 3%. And if you've ever driven a car with a carburetor on it at high altitude, it just makes you sick because it won't hardly run when it gets up there at high altitude. It feels like it's got, you're pulling a 10,000 pound trailer or something. Well, you ever done it? It's bad, ain't it? Feel like you just got a tater in your exhaust pipe or something. All right. One time I was going to make a bug for these guys to find, and I got that Oldsmobile, and I put it out there, and I crammed a potato up in the exhaust pipe. Shoved it way up in there. I did. I just going to let them start it up and see what they could find. And one of those guys cranked that thing up and kept fooling with it and revving it up until that exhaust pressure blew that potato out of there, and it left that tailpipe, and it went across that out there and hit that wall on the other side of that road like a cannonball and splattered all over that wall. I said, you know, somebody been standing behind that car, they probably broke their leg when that potato came out. So I never did that again. It scared me, you know. I figured it'd start up and go dead, you know, but I crumbed a potato up in the pipe, you know. And, well, you know, it's an easy bug to plant. You know, I actually bought a little bag of potatoes so I could do that over again if I needed to. Okay. One cylinder of an automotive 4-stroke engine cycle completes a cycle every how often?
180 degrees.
Actually, one stroke completes a cycle, which would be 4 strokes, right? 4 strokes. How many times the engine got to turn before you get 4 strokes? 720 degrees. 2 crankshaft revs, right? Remember I told you turn the crankshaft 2 times, you've actually displaced all the air that one can do. How many rotations of the crankshaft are required to complete each stroke of a 4-stroke cycle engine? What'd I say? Just now. How many?
Oh, 1.
2.
2.
Yeah. You got to go up, down, up, down.
Oh, okay.
Got it? All right. Which 2 strokes are the upstrokes? What are the 4 strokes?
The first and the fourth.
Well, I mean, which 2 strokes? You got intake, compression, power, and exhaust. Okay, which 2 strokes are downstrokes?
Intake and compression.
No, compression's an upstroke. Intake is a downstroke.
Intake, compression.
Compression's an upstroke because it's squeezing the air. Huh?
Intake and
Intake's down. What else is down? What other stroke is a piston going down? There's 4 of them. 2 of them are up, 2 of them are down.
combustion.
Are you guys thinking combustion's a good? Yeah, it's a good answer. You just had to think about it for a minute, didn't you?
Yeah.
Usually you don't get a question like that. What are the 2 upstrokes?
Compression and
Compression and
Intake.
huh?
what's the downstroke?
No, intake's a downstroke, Dodo. What?
Just said it.
Compression and what? There's 2 upstrokes. Compression and what? You guys are getting drawing a blank here. Oh, this is amazing to me. Somebody asks you a question, put you on the spot, you just say, duh, look at it, deer in the headlights.
Exhaust.
Exhaust, exactly. You knew the answer. You just said here. How what happens is if somebody asks you a question and they're looking at you, you shut down. Have you ever noticed that? I mean, how you shut down when somebody's looking at you when you ask a question, you know? I used to have this easy little math problem I would ask people. And if you ask them, it's easy enough to solve, but they're sitting here because you're looking at them. And their whole mind just shuts down, you know? Let me see. Technician A says the crankshaft determines the stroke of the engine. Technician B says the length of the connecting rod determines the stroke of an engine. Maybe a tricky question, but what do you think?
C.
Huh?
No.
All right, you better. What do you think it is? The length of the connecting rod? Huh?
Will be.
B.
A.
B. B.
All right, watch this. What does a crank look like? Right?
Yeah.
That's what a crank looks like. I mean, if you're just gonna, like a little jack-in-the-box crank,
Oh yeah.
okay, the stroke of the engine is determined by this length of this. Got me? It's not determined, it doesn't matter if you've got a rod that's this long, or if you've got a rod that's that long. The stroke is going to be the same. This is what determines the stroke. You understand? The length of this is what determines the stroke. You're focused? You understand what I'm saying?
Yeah.
The length of this ain't going to have a doggone thing to do with the stroke. It's going to change the position of the piston in the cylinder. But the stroke is going to be equal to this. Got it? And it's going to be twice this, actually. It's actually going to be equal. When this turns all the way around, it's going to go all the way back down to here. And so you're going to have that much stroke. Now, I actually exaggerated that to get the point across. But remember, the crankshaft is what determines the stroke, not the length of the rod, right? Okay, the technician A says the four strokes of a four-cycle engine are intake, compression, power, and exhaust. Is he right? Is he right?
Yes.
All right, suck, squeeze, bang, blow. Remember that. Okay, technician B says most engines rotate clockwise as viewed from the rear, which would be the flywheel end of the engine. Is that true? No. If you're looking at an engine, if you're standing in front of an engine, like in a pickup or something. Now, there are caveats to this. How do you look at a front wheel drive car that's got a sideways mounted engine and tell which way that engine is going to turn? It always turns the same way the wheels roll when you're going forward. And on some engines, like some of the little Hondas and some of your Mitsubishis and some of these other cars, they've got the doggone engine in there backwards. They got the timing belt over on the driver's side and the transmission on the passenger side, and those are going to basically turn backwards to the engine that's put in there the other way. Else you'd have to build the transaxle with four reverse gears in it, or whatever, you know what I'm saying? So basically that's, always just remember that. But if you're standing here looking at like a Chevrolet or a Ford or a Dodge or something, or any kind of car that's got the engine mounted in it straight, when you're looking at it standing in the front of the engine, it's going to be turning this way. When you're sitting in the car, it's turning the other way. Is that easy to remember? Remember that. Why do you need to remember that? If you're turning a crankshaft, you don't technically need to turn it backwards a lot, because that causes sometimes, and won't always, but sometimes it causes timing chain issues if you turn the engine backwards. So you always need to turn it in the direction that it runs if you can. That sensible to you? You understand what I'm talking about? All right. I have to say this stuff, and you guys have got to learn it. So if I come up and ask you one of these questions just off the cuff while you're out there working on putting the manifold on the Lincoln or something, are you going to know the answer?
Probably not.
Or you have forgotten it? Okay, it's going to go like that. What if you go to a job interview and the guy says, if I stand in front of my pickup truck, which way is the engine turning? And you're supposed to have gone through automotive. And you say, I don't, we talked about that, but I forgot. No. He says, okay, we're not hiring this guy. You need to sweep the floor over here or something else. We're not letting you pick up a wrench. You know what I'm saying? You know, it's really kind of, if you go and they say, tell me what EGR is for. and tell me how an oxygen sensor works, and explain to me the 4-stroke cycle, and what's the difference between an Atkinson cycle and a conventional engine.
That's what they told me was wrong with my truck.
Huh?
That's what they told me that was wrong with my truck.
Who's that?
Keep it 4, please.
What'd they say?
EGR.
EGR? Yeah, I wouldn't doubt it. It's probably all coked up. You need one?
Yeah.
$289.95 plus tax. And that's just to put it on. All right.
Ain't bad as I thought it was gonna be.
Yeah. Yeah, they coke up really bad, them things do, yeah. All right, especially if you don't, if you drive them the way you drive yours. All right, then, let me see here. The volume in the cylinder above the piston when the piston is at the bottom of the stroke compared to the volume in the cylinder when the piston is at the top of the stroke is referred to as what? Let's try compression ratio. How big is the combustion chamber when the piston's at the bottom, and how big is it when it's at the top? If it's 10 times as big when it's at the bottom as it is when it's at the top, that's 10 to 1. Hear me? That's how tight it's going to squeeze the air. The compression ratio on a diesel engine is usually 17 to 20 to 1. On a gas engine, it's usually 8 to 10 to 1. On a hot rod, like a muscle car, it'd be like 12 to 1 or something like that. All right, let me see here. Where are we at here? All of these can happen when engine compression is lower than normal, except what? A, harder to crank engine. B, poor fuel economy. C, easier engine cranking. Or D, low power. What do you think about that? It's going to be easier to crank the engine when compression is low, isn't it? I would submit to you also that if you listen to an engine that's spinning over out in the shop, you can tell if it's got low compression on one cylinder, because one that sounds normal will go wah, 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 and one that's got low compression will go wah, 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 wah. So,
Is that the same thing you showed me that day?
yeah,
That was in there?
absolutely.
Yeah.
If you listen to it, you can tell if it's got low compression on one cylinder. So let's think about this for a minute. Let's say you tell your helper, pull that car in here, we got to see why it's skipping. And when he starts it up, your ear detects that it goes wah, 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 wah. Then when he pulls it in, you say, this thing's got low compression on one cylinder, but I don't know which one it is. And he's going to say, wow, how did you know that? If you're just paying attention, when you listen to one spin over, you can tell, right? Okay. A dual overhead cam V8 uses how many camshafts? 4, 3, 2, or 1? 4, that's good. You were paying attention, weren't you, Curtis? A metric unit for torque used by most original equipment manufacturers is what? The metric unit for torque? Wait a minute. Metric unit for torque? You guys are talking imperial there. Newton meter. Newton meter. One cylinder of an Otto 4-stroke engine completes a cycle every how often? 720. That's right, he's remembering. How is diesel fuel ignited in a warm diesel engine? No, it's not. Glow plug. Whenever you crank your diesel, duh, the glow plugs burn when it's cold, not when it's warm, okay? Now, there is a little afterglow when it starts. They burn for a little while to make sure everything's going to run smooth and to get rid of white smoke, but it's compression. And here's how that works. If you take air and you squeeze it with 450 pounds of compression, you're going to get 2 degrees Fahrenheit for every pound of compression. That's about 1,000 degrees air. When that air is 1,000 degrees and you shoot some fuel in there, what's going to happen if you shoot atomized diesel fuel in 1,000 degree air? It's going to explode and it's going to push the piston down, right? You understand that. Compression is what fires a diesel engine. The glow plugs, why are the glow plugs even necessary? Because that heat that's generated by the compression, if you've got a cold cylinder head, you got cold pistons, you got a whole cold engine block, all that heat you've made when you're compressing it's just going to warm up the block a little bit, and it's not going to be hot enough to light the fuel off. So you burn those glow plugs to provide that heat. It fires up. Got it? You can put too much fuel into a diesel when starting, and it will not start too.
That's what mine did when I was down in Panama City.
Yeah, and it just puffing out all kind of white smoke and all that. Yeah, that's right. Okay, let me see here. What fuel component is used in a vehicle equipped with a diesel engine that's not usually used on the same vehicle when it's equipped with a gasoline engine? What about a water fuel separator? Diesel fuel has got a water fuel separator on it. Gas engines don't typically have that. The diesel injection pump is usually driven by what? What usually drives the distributor? A gear off the camshaft, right? About the same thing. Think of the diesel injector pump on one that's got the lines with that. Now here's something else a lot of people don't realize about diesel engines. You know, whenever you look at one of these diesel engines and you got all these little stiff metal lines going to your injectors and all that, yours ain't got that. Yours has basically got an oil rail built into each head. You know what I mean? That's what you got on yours. But the ones that's got an injector pump on them, it sends little bursts of fuel up through there to pop those injectors and spray the fuel in there. Those lines have all got to be the same length. You cannot have a shorter line on one injector than the other, or you'll cause a misfire. They also, when they're bent, they can't be bent tighter than a certain radius. Most people don't know that, but that's just part of the deal with a diesel engine. It's a different world than a gas burner. You still got pistons and valves and stuff, you know. But all right, let me see. Let's see. Which diesel system supplies high pressure diesel fuel to all the injectors all of the time? Just looking at those answers, which one do you think it would be?
A.
High pressure common rail. That's not what Quincy's got. Quincy doesn't have high pressure common rail. Quincy's got a 6-liter in his Power Stroke, and it uses high pressure engine oil to operate the injectors. Now you will have from 55 to 80 pounds, I think, fuel pressure fed to the injector, but that's not enough to pop those injectors. Glow plugs should have high resistance when and lower resistance when. Higher resistance whenever they're warm, and when they're cold, they got lower resistance. Now, you can take, let's say that Quincy's truck was missing on one cylinder when he first started it, but then it smoothed out. You can go to the wire that's feeding the glow plug, and you can take our charging system tester that's got an inductive amp probe on it, and you can actually clip it around the wire going to those things, and when you turn it on, you're going to read the total current that all the glow plugs are pulling. You know, if you can find the one that's actually feeding the glow plug. When they first turn on, they're going to pull a lot of amps, and they're going to drop back and pull less amps, and then they'll go off. If you know how much a good one pulls, like for instance, only old 7.3, you'd get 200 amps. It's 25 amps per glow plug. On the one like Quincy's got, I don't know what that reading is, but you'd have to measure it on a good truck to get a good thing. If you measured 175 amps on a 7.3, which is 25 amps per glow plug, you know one of those glow plugs is not working, right? You know, it's actually burned out. So there's all kinds of cool little things you can do real quick to find out what's going on. What part should be removed to test cylinder compression on a diesel engine? Anybody know? How about the glow plug or the injector? Either one. You got to have a special adapter to go down in there, and that's how you check it. Technician A says injector nozzles are either opened by high pressure pulse from a distributor pump, or electrically by the computer on a common rail design, or on a high pressure oiler design like Quincy's got. Technician B says indirect injection occurs directly into the combustion chamber. That there's going to be A is going to be right about that one. Which one of these takes place during regeneration in a diesel particulate filter? What happens there? Soot is being burned. Did you know if you drive a diesel engine with a particulate filter on it through downtown Los Angeles, the air coming out the exhaust pipe is cleaner than the air going in? In other words, the engine is taking in air that's dirtier than what it's putting out. I also heard today that because of the little bit of extra carbon dioxide we got in our atmosphere, the rainforests are just growing up a storm down there. They're happy with all this extra CO2, which is actually coming from plankton in the ocean, not coming from us. But a little bit of an increased carbon dioxide, wherever it's coming from, is really making those rainforest trees happy. Does that sound like we're going green to you guys? Put out some extra CO2, you're going green, man. Cut it off, the rainforest is going to come hunting you. He's going to want to choke you for cutting off his air supply, right? All right. Now, rainforests are good, right? They're our friends. So we need to put out more CO2. Okay. What color exhaust smoke occurs most often during cold engine starts? And this is on a diesel, because the smoke is usually condensed field white smoke. You've seen that, haven't you? That's bad news. Were you all upset and disappointed when your truck wouldn't start and it was puffing out white smoke everywhere? What was wrong with it?
What was the EGR?
Yep. Selective catalytic reduction, SCR, uses urea injection to reduce what?
CO2.
Huh?
A.
NOx. The diesel exhaust fluid is injected where? It's injected after the oxidation catalyst. A lot of these vehicles are using, exhaust fluid now. Good idea to keep it.
What was 6 and 9?
Which one?
6 and 9.
9. Which one?
6 and 9.
Oh, I thought you said 69. I didn't have that many questions. Okay, somebody tell her.
He can't tell me because he can't get his crap together.
Technician A says the crankshaft determines the stroke of an engine. That's what I was drawing up here. Does he? Technician B says the length of the connecting rod. Is he right? The picture I drew on the board told you the answer to that. And then 9. It's harder. It's not going to be harder to crank the engine when the compression's lower. There may be other reasons for that, but it ain't going to be because of low compression. Everybody got it?